At the end of this lesson, you'll be able to set up the cam and calibrate the handle mold tool. Face off the mold, perform and simulate adaptive clearing, perform and simulate pocket clearing, perform post-process and create a setup sheet, and learn all about whole systems design, life cycle thinking, and 10 engineering design principles. So we're going to look at manufacturing a mold for the handle that we designed earlier. We've actually created a mold block simply by, if I just turn some parts off here, I can show you. Got the handle, then created this block, and then combined the two entities. Then we take away the handle, and we're left with the mold tool. To begin this lesson, select Handle Mold Tool from the dataset, then select Model, Cam. We need to enter the Cam workspace. Okay, so with the mold tool in front of you, select Setup, New Setup. This opens up a dialog window, so we need to make sure that we've got the operation type set to milling, and then we can also set the work coordinates and the orientation. Well, we can see that actually the orientation is wrong here, because on a normal CNC machine, the Z-axes would be pointing upwards, and the X and Y are also the wrong way around. So select orientation, select Z-axis plane and X-axis. Then for the Z-axis, we need to select the top face of the block. So select the top face of the block. Now we can see that Z is pointing the right way. But X and Y are still in the wrong place. So for the X-axis, make sure that you select the front left-hand face here. Now we can see that X, Y and Z are all pointing in the right direction. One final thing we must check is the origin. So when you're setting up this on your CNC machine, the machine needs to know where the origin of the material is. So if we select the origin as a selected point, I'm going to select this front corner edge here as the origin. Now if we select the Stock tab and then select Mode Relative Size Box and then Stock Offset Mode to No Additional Stock, we're going to use our block, which is width 125, depth 85 and height 25. Click OK. Okay, so ensuring that we've got Setup 3 selected, go to 2D and select Face. Make sure that we select the right tool, and we're going to go for a 50mm face mill tool. So select OK, and now we need to just check the geometry, and in the tab for stock selections we need to make sure that we select the top face of our mold. And if we look at the heights, we can see that all the heights are great, don't need to do anything there, so just click OK and it's done. So if we want to simulate this just to check that it's doing what it should be doing, if you right click on T1 face and select Simulate, then press play, you can see it there skimming right across the top of the mold. So that's great, that's absolutely fine, that's just what we want. So now that that's complete, we're going to have to just cut out the main contour for the handle itself here. And because it's a 3D contour, we go to 3D and we want to select Adaptive Clearing. Okay, so we have a dialog box here and you can see that automatically it's selected a 50mm tool. We don't want that 50mm tool. We need something that's going to give us more definition. So I'm going to go for a 6mm bullnose cutter and click OK. Now if we go to geometry, we need to check that we've got the right stock selection. So we select the face of the contour. And if I have a look at the clearance height and then use the view cube to see the front, I can see that's all good. So just select OK. Now it's working. You can see there it's starting to cut out the paths and it's done. So if we want to simulate this, we need to right click T2 Adaptive 2, select Simulate, and then you can see the simulation of it cutting out the contours for our handle, which would be injection molded here in this tool. So one last process we need to go through is we need to check pocket clearing. And this is really the final process that gives a really nice smooth finish to our final plastic injection mould, which we'll produce from this mould here. So we're going to use the same tool here, and the geometry is the same. It's the same machining boundary, so click the top edge. Just ignore the warning for now, and it's done. We can simulate that again by right-clicking, select, simulate, and playing it. And we can see that's all great, so I can close that down. Now click the complete setup in the browser, then click Actions, Post-Process, click Post, and then save the file. This will open up a new window where we can see all the code, and if you're familiar with this GNN code, then you might want to copy and paste that into another document so that you can run it on a specific type of machine, or you can edit it, etc. Whatever you need to do with it. There are some other tools here that we can just take a quick look at. If you select Action, Setup Sheet, then select the folder. This again will launch another window, and it gives you an entire setup sheet, which is essentially a job sheet for your material, which is very, very useful. If we return back, we can inspect the tool like we would any other design in Fusion. And we can also manage a tool library. And finally, we can create various add-ins.